So this is day one, and my goal is for you to find the area between two curves. Please note that there is an upper function and a lower function, and the upper function is the one that is bigger than the lower function as far as the y values are concerned. And the key idea is when you find the integral of this, of any function, you are finding the area under the curve. Weirdly enough, you were always doing it between two curves. So for example, when I had given you a function and you found the area under the curve, you were like, oh, it's just finding this part from A to B, right? But technically it kept going the whole time. But when you found, if this was f, when you found the integral of f of x, there was this like -0 going on. So that would be this line. This is y equals 0, which would be kind of cutting this part off and leaving you with this. So you kind of been doing that the whole time. All right, well, let's get into this. So basically you take the area of the top minus the area of the bottom, and that gets you the area in between. And that's it. That's how it is. Now, interestingly enough, we may be dealing with functions that are sideways as far as not having your delta x be going up and down, making rectangles to find the area between the curves, but going this way. So it's going this way, so it's right to left. So you're not having delta x in here, you're having delta y. So when you do your integral, it's in terms of y, and these are y values. This is the y value here from C to D, C to D. Whereas here, more popular, is delta x, and it's going from A to B, and these are x values. So x values, the function in terms of x, dx. The y values, these are y values, the function is dy, and these function is like y in the equation. So it's x equal with y in it, and x equals y in it, where this is y equals with x in it, y equals with x in it. Hopefully this makes sense a little bit as you do it, okay? The process is a little easier sometimes than the concept. So what would you be expected to do? You would be expected to find the area between two functions. This one is saying you're allowed to use your calculator, but typically I don't believe that this is something you would normally be allowed to use your calculator for on the AP. So, but this is new, so if you use your calculator, it's fine. But you should be able to kind of get a grasp of this function and what this looks like, right? So hopefully you caught on to the idea, oh, don't fall, okay, the idea that this is a parabola, and this is a square root x function. Maybe I can use that, right? So this is y equals square root x. This is y equals x squared, right? So now I want to find the area between the two. So if this is my A and this is my B coming straight down this way, I would need to know what that value is. So I would need the intersection. Okay. So to get that intersection, you basically have to set the two functions equal to each other. So you go, since it's y equals x squared, I would have x squared equal to square root x. You square both sides, and you would have x to the fourth equals x, okay, right? Because that's because I squared both sides, right? And so then I have x to the fourth minus x equals 0, so I can factor. So that would give me x equals 0, x cubed minus 1 equals 0, x cubed equals 1, so x equals 1. It doesn't need a plus or minus because this is a cube root. So cube root doesn't require a plus and minus, only the even roots do. Okay, So now you have these two. So now what do we do? So now I'm going to take these two values, and you can see on the graph that it makes sense, because on the graph you have here 0, x is 0, and here is x is 1, right? So there you go. So you're like, okay, cool. I am just going to find the integral from 0 to 1 of the top function minus the bottom function. That becomes a thing. Finding the top function minus the bottom function becomes a bit of an ordeal. So you have to just look at this and be like, this is my top function. So that is my square root x function. This is my bottom. So if you look at this, this is square root x, and this one is the x squared. Top, bottom. So square root x minus x squared, top, bottom, and this is dx. So I know I can just type this in my calculator and get an answer, but I'll just do it, you know, or you can just do it by hand. It doesn't matter. It's not that big of a deal. So this would be x, this is the 1/2 power, so plus 2 over 2 would be 3 over 2, 2/3, minus x to the 3 over 3, and this of course is from 0 to 1. You plug in 1, 2/3, 1, 3/2, minus 1 to the 3rd over 3. Why are my 3's looking so lazy? Minus 2/3, 0, minus 0. And of course you should run through this, get 2/3 minus 1/3 minus 0. So then that ends up being 1/3. And if I remember correctly, I had gotten the same answer. So the area between these two curves is 1/3. So it's a pretty small area. All right, next one.